Hi there everyone. This is going to be sort of a walkthrough of a series of starter projects that I've put together in Pops. And this is going to be part of a larger series on kind of resource building and learning how to use these tools. I'm going to go through these examples in 3 stages, and these are also how I've kind of sorted these in terms of how I'm making these outputs available. So all the outputs in this section here are more utilitarian. They're things that I think are really useful operations and things to know about when it comes to POPs. And this is going to be made available on my Patreon for free. The other two levels are part of the patcher and component area of the Patreon. So the patcher will show some more advanced capabilities that POPs have. And I'll show you those later, but things like the attractor that we looked at before, working with tops to pops, and this life module that I've made. So these are things that are utilizing a bit more of the mathematical qualities of pops. And then we have the component level, which is going to be more high-end things. Again, these are more sort of fully formed projects that show how I'm incorporating pops in various ways into these projects and making stuff happen. And I've been really enjoying this sort of workflow so far, and kind of look forward to doing more of these tutorials and building more modules to show you. So what I'm going to do, because my computer is going insane, is I'm going to turn these off. I don't know if you can hear that big old fan, and I'm going to start off going through some of these more utilitarian ones, which I think are the most important to understand in terms of thinking about how to work with pops. I'm going to start working with these boundaries, boundary 1, boundary 2, and boundary accelerate. And what I'm trying to do with some of these earlier examples is draw comparisons between generative art techniques in software where this is kind of foundational, like P5.js. So if we go and look at this P5.js sketch, we can see that this is basically the logic for how we'd work with these vectors. We'd make a series of particles and we give them a velocity, and when they intersect with a wall, that velocity is going to be reversed, and so they're going to bounce the other way, or give the appearance of bouncing the other way. And so here's the code for that. So what I'm doing is I'm attaching this, and it's also available inside these projects, so we can actually see that processing code running in an HTML instance as well. And this is really so you can see how these fundamental concepts of generative art can be transferred. Before I start, I also wanted to give a shout out to some of the tutorials that I've seen coming out about pops that I think have been really cool to watch. So we've got function stores, pop particles, Andrew Sun, physics in TouchDesigner pops. Really useful to watch if you want to get more into working with math and sort of these generative art vector-based operations. Really, really great. And I think there's going to be a lot more cool tutorials from Andrew coming out. And also recently we have the Simon Alexander Adams polyhop shape morphing. So there's a few things already out, and I'm sure there's probably more by the time that I post this video. I also have some videos out. I've got TouchDesigner Pops, and this is sort of a follow-up to this video. In this video I talk about some of the foundational areas of pops, but in this one I go further, and I also have a pop tutorial where we build an attractor, and I'll be publishing more tutorials and resources over the coming days. So okay, let's go to this object and look at what this is doing. And what I have tried to do in these examples is I have also tried to sort of go step by step and move through how this is used. So if we look at the logic of this code, basically we have these vectors that are being created, and this is kind of this idea of translation. Before we look at TouchDesigner, we basically create a number of particles. In this case, what I'm doing is I'm creating a point and I'm copying it, and this is my starting position. In this case, 100 particles, and I'm feeding those into an array. Obviously, we don't have to do this in TouchDesigner because that's all done for us. But the main point of what I'm trying to get across is we apply a random velocity to these, and this is essentially the movement in XYZ. So each value is going to have an incrementally increasing value that creates this step, and then when it reaches a boundary, we reflect it by multiplying that velocity by -1. So if the velocity of the X channel was, say, moving in a direction of 0.1, then the direction would be multiplied by -1, so then it would be -0.1. So it would reverse that operation, which allows us to have this reflection as things move off the walls. And I've tried to kind of lay this out step by step. So the way that I set this initial velocity value is with a random. So we create our points instanced on a sphere using a copy, and then I'm using this handy random object to create velocity. And to do that, what I've done is I've gone inside and I've combined the operation, or the combine operation I have set to set. And so this means that it's not taking any of those values that occur previously, it's setting its own set of values. And I can set a randomized range between value A and value B. So in this case, I've left it quite small. I can increase that, and because this is before a feedback, I have to just press my feedback to re-instance that. And we can see those velocity values are now a lot higher. So that movement is going to be much faster. So let's go back down. And so this is like the scale that I'm moving between. And I put this into a feedback, and this is essentially going to allow me to have these operations updating over time. So I have all of these movement parameters essentially. So I've got my velocity, my boundaries, my reflections, all within this feedback loop. So this means that the values that I have set out are going to be moving over time, and it's always handy to look at these things using a pop viewer. If you want to, you can hit this transpose tab and look at it at a different axis. But essentially we have our indexes, so these are the values in index terms of each point, so incrementally, basically the value, or the index value of each point, so it's just going to be its kind of index. Fairly simple, we don't use that. We have our 3 point positions, so we can think of this like a vector in 3D. We have this invert value. So the invert value is responding to a sort of a Boolean operation. So if it's true or false, it's going to be flipped by max bounds. So basically invert is going to flip when we have a max boundary hit, and these are happening very, very quickly, so we can't see too clearly when this happens because it's just going to flick. We could see there we've got a couple of things that have changed, but that is feeding into our system this change in direction. And then obviously we have our movement, which is what is powering our particles, and then obviously the velocity that we're moving in. So I'm going to delete that, and I'm going to walk us through some of these objects I've put here, and these are all math mix objects, and I've tried to sort of set out what's actually happening here so it's easy enough to step through when you go through this. So the first thing that I'm doing is I'm just creating a movement value. So movement is what's going to basically be this position plus velocity. So what I'm doing is I'm adding my position, I'm adding velocity to my position, and then as a result scope, I'm calling this movement. And this means that I can update this movement parameter without interfering with my actual point values. And I can apply this when I'm ready to. So I can kind of go through this whole chain. And theoretically, you could just create everything in one math mix. But for my brain, I find that a little bit confusing to have this long chain of operations. So what I've started trying to do, and these objects are also fairly new, so I'm kind of experimenting and seeing what works for me. And what I've found is that kind of having individual operations segmented in different math mixes works for me. And the attributes that we're creating, like for example movement, that feeds forward. That is now a new attribute that is this operation that we've created. So when it comes to boundary, I'm using these operations here. I've set a uniform here for my boundary. So I've set minus 0.5. So this is basically the low end of my boundary and minus and 0.5. So if I go in and set this lower and set this higher and restart that, we'll see that the operation now is going outside of my box. So this is basically a way for setting where your boundaries are. And for whatever reason, I'm finding that my undo isn't working. So let's just do this and press to reset. And so basically what happens is when a boundary is intersected with, and it can be a little hard to see here, when a boundary is intersected with, it's going to basically give us a 1. So basically this, we can think of this as a Boolean statement. So if it is true, it's going to be 1. And if it is false, it's going to be 0. So basically these are Boolean checks. And so once I've set up those min and max uniforms, I'm checking if the movement value, so this is my position with that velocity vector added to it, so over time this is going to move in a direction. If that goes over my minimum or maximum values, it's going to return a 1. And so that's what I use to then power my reflections. So ultimately, what I want to do is I want to multiply my value, and we can see here, is basically when I hit a boundary, I'm multiplying my velocity by -1. And so I don't actually want to change my velocity in terms of its speed, I just want to change its direction. So by inverting it, I make sure it goes in the other way. And this happens for both axes, so the reflection on the far edge and the near edge, or the min and max edge. And so this is kind of the operation here. And so basically I have to do a little bit of hacky math to get this this inversion. For whatever reason, I am still struggling doing some of these operations in these math combines versus just writing it out in code. But basically what I'm doing is I start out by multiplying the minimum and max bounds by 2. And the reason I'm doing that is I want to actually have a number that goes from -1 to 1. So it's either going to be -1 or 1. And so just having this little operation here, 2 times min/max bound, I can then apply this multiply 1 to my invert value. So basically that allows me to just jump between -1 and 1. And then I'm multiplying my velocity by the invert value. So if I bring up the search bar just to show you, if I say have a velocity of 9.9 times -1, be minus 9.9. So basically it just flips that from being a positive to a negative. So essentially a reversal. And then I add that value to my velocity and output P. And I do this for the min and the max. So basically we can see here that I'm looking at the max boundary, and here I'm looking at the min boundary. But apart from that, everything is exactly the same. You could stack all of this into one math object if you chose to, but obviously in this case it's easier for me to think about these kind of operations as these individual elements. In terms of just a little bit of post processing on that, what I'm doing is I've attached a trail, and the trail is giving me a length. So we can see obviously when I take off that operation, it becomes really big. But basically I can set a trail length. You can set it in seconds or frames. I'm choosing to do frames because of this following math operation. If I turn off this math operation, we can see that one, it's quite big because I haven't scaled it down. But two, basically what is happening is if I went just in this direction here, by default, the age of the particle increases as we get further away. So as the particle gets older, its age increments in frames, right? But what we want is we want the largest circle, or the largest sphere, to lead our direction. And right now, the largest circle is at the end of our chain because it's the oldest. So what I do here is I just add in a math chop and just take the age. I've linked my max frames to my map from high here, so that means it's going to start from the same point. So the low point's always going to be 0 frames, the high point will be 60 frames. And I'm mapping whatever I want my largest size to be to 0. I just have a circle or a sphere in here. If you wanted to not have such a large output without having that transform, obviously you take that down by putting a transform in there and instancing that. But this is something that obviously is super useful, being able to control things just in terms of particle size by age. And this is something that's really easy to do when we're creating our own systems using trails outside of thinking about things like the particle chop. Okay, so that's basically the logic for the first boundary. The second boundary is very similar. Some of the changes here is I've just added in a replicator to create 3 families of particles, actually 4 in this instance. You could add in more if you wanted to. And each family has its own color that will be randomly generated on start. And let's see how that happens. So the color is being added by this attribute. And so this also shows you how you can add attributes into your kind of endpoint of objects, especially if you're working with multiple kind of systems that you want to pair together. In this case, I've created a color attribute, but you can create anything you like. So you can create a custom attribute. So for example, let's say CA for custom attribute. You can then select what format you want it to be in. You can select how many positions you want, so you can have up to a RGBA output or a 4-channel value. And so what I'm doing here is I just add that in, and it allows me to just feed that color forward into the system. And so each of these little systems is colored by its attribute. And what we can see, which is I think a really nice effect with this line connector, and we can also see that there's not that much stuff I have to do to then just get this together and instance it. What we can see is we actually get this really nice gradient as we move from line to line, which I really like. So I think this is quite successful. Okay, moving back. And the last one in this kind of series is showing how we would apply acceleration. So in terms of what we've done already, we've applied a velocity, and so velocity allows us to go in a specific direction, but really just in a straight line. Acceleration allows us this extra axis of control. So we can see here that by adding acceleration, and let's look at the accelerating example. By adding acceleration, we can create these sort of curving moments that feel a bit like a noise-based system. If we look at the code, what we can see is all I'm really doing is I'm adding acceleration to my velocity. And I'm also limiting, because if you keep adding an acceleration, obviously at a point it's going to get really fast. So you want to limit the top level of value for that acceleration value that's going to be attached to the velocity. So limiting that velocity after acceleration is added. So that's kind of what we're just adding in there. And all we really need to do to achieve this effect is, we can see here that I've taken another sort of noise, or rather than random, which I was using before to set those attributes, I'm using noise, because I can also have some kind of axis of change there by translating that 4D, so that the acceleration does change slightly that's applied. I guess this is just a null, and I'm feeding in to this acceleration, this extra math combined or math mix that adds acceleration. So what I'm doing is I'm basically just adding acceleration to my velocity, like we saw in the other sketch here, in that processing sketch. Let's zoom in on that. And we're getting the same effect. So basically, just if you have a bit of a basic knowledge of looking through some of these generative art guides, especially with creative coding and working in P5.js, you can recreate that methodology fairly easily step by step using pops. The thing that's kind of added on here is I have this dampening factor, and so basically that just means I can control in this uniform how much that acceleration is going to affect. So basically how the multiplier, if I multiply by less than 0, it's kind of crazy, but if I multiply it by less than 0, it's going to sort of just dampen that value, and then I'm multiplying my acceleration by that value just to create a dampened version. So I'm just adding essentially that acceleration, but I have a little control there to dampen it, which I think is super nice. Before I move on to some other things, I'm just going to return to this boundary really quickly, and I'm going to show you one thing that I think is kind of useful. So what we can see here is I have instanced these different starting positions, or I've positioned these different starting positions, so every time I press the mouse it's going to start in a different location. My computer is a little slow today because I have a lot running on it, but basically the way to actually access the information about these pops is to use this kind of logic. So what we can see here is I'm using that sphere as my default, and because this is in a replicator, I'm using things like the parent.digits just to identify the digits. But what we really need is we need to get the operator. So in this case it's the set pos, so this is in the out a layer, and we want to get points. In the name is going to be p followed by a 0, and then we want to get the 0. So we have two arrays that we're accessing. So this can be whatever the parent digits are. So this is essentially if it's the first, second, third, fourth, however many instances you have. In this case I have 4, so it's going to be 0 for this one, the next one will be 1, so accessing that index, so I can then access the x, y, and z points of that point position, and we can see there that it's moving around as I re-instance that. So that's just something useful to learn and to look at in this sketch, because being able to utilize that kind of just referencing without having to then pull it into a chop and then get the data from there and then reinsert it saves you a bit of time. So that can be kind of useful. Okay, let's make this back to a panel. Some other things I wanted to show you. I guess this is open, so let's do this. It's also a top. So this is basically finding the difference between points and how you would kind of instance that or put it into space. And so here I have my line. My line is just a unit value 111. And I also have a noise. So the noise is distorting this grid. And so we can see we have a grid and a noise, and in this math, I'm just subtracting. So my input 1 from my input 2. Also, my original position is the value that's being subtracted, and I create this difference value. And what I can do is, if I take this into copy, we can actually feed forward these types of values. So if I just create a copy, and I'll put this in, and then this in, what we can see is copy by default is just giving us this, it's just instancing that line essentially. It's copying that line like we have looked at before. But if we go to template, I can turn on these different factors that we can feed forward. So I've created a size attribute, and so we can see the diff value. And so this is really cool because this could allow you to instance in sort of more exciting ways, just using the copy and feeding that to a geo and adding in rotations. So this is really a useful thing that you can do with the copy tool, is you can actually feed forward different attributes and apply them, which is really nice. Oh yeah, we want to make sure that's still going there. We'll just go back. Okay, so this is the copy one, super useful. We have centroids, again a fairly basic system, but we can access centroid positions. My network's all messed up, but anyway, we can access our centroid positions by using an analyze chop. So we can look at the average, the centroid, the minimum, the maximum, the sides, all these parameters, and it will feed us out a series of values that we can access in a chop to then instance. So I can then move my 3D sphere here to wherever the center of that point of spheres is. Likewise, if I just add in things like the average, I can add in other areas that I want to monitor. So the analyze chop is really useful, and then you can kind of bring that into your projects to analyze where central positions are in various networks. We also have this proximity chop, or proximity pop, that I've talked about before. It has 2 inlets. So if I don't connect to that second inlet, we can see that these circles are connecting based on their proximity in this point-based network. Once I add in a second input, it's going to look at the geometry that I'm feeding it and try and connect to that geometry. We can see that no longer are these spheres kind of looking for each other in their own point cloud. They're connecting only if they're close to this central circle. And then you have like these minimum and maximum distance controls. So again, some super useful things here. We can do a few other cool things which I'll quickly touch on. So blending we can do, and so this is automated. I'm just kind of blending between some 3D shapes. Oops. And I can also switch between these so we can see something that is a point-based version or a mesh-based version. Another way you could do this, I'm just doing this using the blend pop. I've set it up to have blend differencing, and what's cool about this is it allows me to blend between multiple inputs. I could also put in more inputs, and it's going to blend between the multiple inputs in different ways based on your controls here, so that's really useful. You can also choose if it's proportional blending or smooth blending, so you can get different effects based on what type of blend you use. If you use the math mix, you also can do a form of blend using the mix ABC. So the first 2 values are the values you want to mix between, and the C value is the sort of the amount that you want to mix this is kind of cool because you could apply that in on a more granular level, which we'll look at in the next example, which is this color mix. So in this color mix, what we have is we have this input image, which I'm using as a lookup texture. You can see here I've just taken that in as Thresh 1. So just drag the top that we want to work with. That's our lookup texture. In this instance, I have two images, and what's happening in the math mix is I'm using my ABC value. So I'm using color 1 and color 2 to be mixed between using my mix value. In this math value, I have I don't actually need this at all. I was just trying to play around with a few things, like just changing some of the logic here, which wasn't really working. But what you could do is you could change that multiplication on that mix and see different ways that could impact. But by default, I'm not really applying that. But it could be interesting, especially if you go to length and multiply in different ways. I'm actually going to just take that out because it's actually not going to be useful for folks really in terms of this example. But basically what's happening here is I can mix between using this texture. And this could be an interesting way of thinking about how you might create more complicated systems that have different types of mixing. So maybe you have a set of geometries that are clustered in one area with one kind of application of a mix versus another one. And it doesn't have to just be blending between images. It could be something much more exciting. But in the basic sense, I'm creating this attribute scope from the lookup, which is labeled mix by me. And then that's basically mixing between these two images. So again, something that's pretty useful. Okay, got two more things in this section to go through, and both are, I think, pretty cool. I'm going to save my favorite to last, which is the sort. This is fairly useful as a sort of a method, and this is a way of just checking 3D distance. So basically these rectangles or squares are being instanced in terms of their size by a second by this sort of noise attribute, which is basically controlling where an effector is. If I go down to this smaller block size, we can see more clearly how that is being affected. So if I have my 3D set of blocks, we can see here as well that it's being affected by this sort of central effector. And what I have here is I essentially have a XYZ mix. I also have a scaled value, which is, let's see where my scaling is. It's in this attribute. So I have this scale value that I've created in the attribute, and I can basically choose how much my effector offsets those objects. It's a bit janky, but you can play around with this, and essentially this is how you create a distance check. So we can see here that obviously the fall off as we move from the center, these rectangles get bigger. And let's set that up to be 1. So it's back to being this 3D thing. Most of these things are panels, so you can just go in and play with the panel comp as well. And rotate that around and actually see how these things work. Kind of a useful utility just to know about. This one's not a panel comp, this is a top. I'm going to display that. And so this is the last one in these sort of more foundational networks that I wanted to show you. And so this is the second sorting iteration that I wanted to sort of go through. I did mention this in my previous video, and basically what I'm doing here is I have my input image and I'm sorting it by another input. So to do this, what I'm doing is I'm creating a second attribute using this top 2, and I'm labeling it color. And then when I come to my sorting pop, what I can do is I can select a attribute to sort by. I have all these things that I can do in terms of what type of sort I want to do. So I could do a random sort, or I could do, you know, along a vector, proximity to the point. Could be interesting, but I tend to like to do by attribute because this means I can actually feed something else in. So maybe let's call this sort col, just so it's more accessible. And then in my sort, we'll see that we have all these things that we could sort by. Before it was just color, you know, the second index of color. These color values are the color of our image. So we could just sort by the color from an image, from a channel, which could create an interesting effect. So sort by the red, green, and blue. But I want to sort by this other image that's coming through. So I'm basically just converting this sine curve into a index for sorting, and you can play around with it to create different kind of glitchy effects where it's sorting kind of in weird and wonderful ways. And the final thing here that I'll show you in this network is I do also have a blend. And so as we can see here, we actually can't see a lot of this information at the end of our chain. So one way we can view it is we can just drag out as a pop 2. And here, and let's just do this from scratch so we can see this process. So go to tops and pop 2. And by default, we're going to see the red, green, blue, alpha. So essentially the kind of the normals, or the RGBA, which is controlling the position. And so this is why we see position and active. We want to switch our mode to custom, and we want to, in our attribute scope, set color. And so this is going to allow us to see that through our color index. You also could say sort color, which isn't really going to do much right now unless we switch it. And then you're going to see the sort of the method that's being sorted in. So if I changed my sort mode, you see that's glitching, essentially because as well it's sorting sort color rather than the other way around. So we want to go back to sort color, and our attribute scope will be color. And again, remove that, so we're just looking at one. So you can see that it's a super interesting way of working, where we're working with these attributes that we can stack and use. I'm also showing you how this takes out to a geo, so I can actually instance this as a geo, which we're seeing on this side. If I have it at 1 or 0, we see basically our image. But if I have it in this interstitial blending phase, we actually get to see this very cool sort of almost 3D reinterpretation as the pixels actually move, as they sort of translate in space to try and find the next point that they have to be. In this case, it's just on a moving between two 2D planes because it's the same image. But again, like a super interesting effect. Okay, so I think that's everything in the utilitarian sort of things, and this will all be up on my Patreon for free for the yellow operators. And these two sections are going to be in the paid versions. So I'll do a quick walkthrough of these to show you what's available. So first up, we have this attractor, which we have looked at before in my attractor-based tutorial. And so basically what I'm doing is I'm using the math mix to create a chain that allows me to position an attraction force and pull together, creating all those attributes, trying mostly to do it in one or two math objects. And we can see here there's got the logic there as well. I also show later how to scale it up to more things. This is an example of how we can take a top data, which I'm playing with here. So basically it comes in as this. So it's basically working with this noise multiplying a ramp, and then doing a little bit of math in the math mix to make this look kind of funky. So we've got a math mix and then doing a couple of operations there, no uniforms. And this really was just experimenting with to see what actually looks kind of interesting and good. So, you know, you can also try different operations here. So I could do like A plus B, which just kind of flips it. A tan. I think part of this whole process is going to be just exploring what actually feels and looks interesting to you. So trying to play around with things that might be seemingly a little bit random, but ultimately feel kind of cool. So the normalize feature is also kind of cool if you want to put things into spheres or onto the edges of a sphere. So we have this one, and then finally in this section we have my life component, which I talked about in the other video a little bit more in depth, and basically I might redo this as a less sort of convoluted way of doing this, but what I have here is I have my life is incrementing. So again, I'm creating these random values that essentially dictate where my life starts from and the maximum length of that life. It's being added as an attribute, and then in the feedback loop, I'm incrementing my life value by this sort of step, so I could have it go real fast like it is now, so it will reset maybe quicker, versus a slower increment where it will take longer to get to that maximum life point. Just to create some feedback and interest, I'm using this noise in the feedback loop to displace. I'm again doing Boolean checks. I'm resetting things to based on these checks. So basically, if the life goes over a maximum life value, I'm sort of resetting that back to its starting point. And then finally, I have to also reset that Boolean because in the feedback loop, it doesn't reset, it stays. So once it resets once, if I take this off, what we'll see is it spews out, but then everything eventually returns to its original position. So having this reset will allow me to also reset each of those life on off things, so we get this thing that consistently grows. So these are the sort of the things that are continuing to be utilitarian but a little bit more advanced, which I think are also useful, which I'm sharing here for the patcher subscribers. And finally, for the component subscribers, I have a couple of things that I also think are really cool. And this can show you a bit more about how I build projects using pops. So this is a attractor chain, so it builds on the attractor tutorial and just shows you a very simple way of chaining attractors together in a sort of a chain, and then a few other fancy like post-production things to put it together and make it look fun using things like this proximity. Other things I have going on here is I am also applying a blend. So if I control this blend, I can move between a sort of a flat disk or a sphere, or have it somewhere in the middle where you get these kinds of like 3D pulls on a sort of a more flat object. So also incorporating different start points is quite easy now using these new pop tools, which is also great. And you can use this to blend point clouds So yeah, I'm chaining these attractors together. I have some kind of switch here. Let's see what that does. Okay, that's for pulling things together and adding to the trail. I'm creating things using a trail to pull that stuff together. So this is something that's more kind of just showing you a use case for how I kind of chain these things together, which could be quite useful for folks to look at. And finally, I have something that is kind of similar but has a different workflow, and incorporates a few things like, remember I showed you earlier that distance check. So basically it was the static grid and the noise distorted version of the grid, and basically the line vector is drawn between the new position and the old position just through using math. So this is one of the things that I'm doing here, is all these lines are connecting to the original point and the displaced point. So the start of the line is where that point will eventually return to. And in this network, it's a little bit more dense. And what I'm doing is I'm sort of combining a bit of two things. I'm combining some of the great things about pops that we have, like proximity and combining attributes to define certain areas. Like, for example, the color, which we can see here. I'm kind of attaching these types of attributes. But also I'm working in pixel land as well. So I'm working with some GLSL. I know that there's a new GLSL pop, but I haven't spent much time with that yet, or any time. So I'm kind of still in this realm for now. But basically showing how we can take all this data and convert it into a top to actually do something with. And this is not only I have set this up to be 2D right now. Let's fix that. But it can very easily be 3D. So for example, like we could put in like a sphere. There's a few other things I'd have to limit or unlimit here. So we can see those things are moving. The next thing I'd have to do is, in my GLSL, I have these boundaries. So there we go. So now if I reset that. Okay, so I made some updates and went back to an earlier version, and now this 3D is working to show you how those attractors would work in 3D. A couple of things about this GLSL. We have this inverse square fall off, which will give us smaller attractions. Or more smoothed attractions that we can sort of mix between. And we can also play around with things here. So this is our position, but we could play around with our attractor weights. And you get a little visual there of how strong or small these things are. So if I put up my weights, we'll see that, well, that's actually distance. So this is our attraction weight, and this is our distance. So the sort of the influence of how far away that attractor would have to be to actually pull things towards it. And we can see there's a difference between when something is purple and blue. Each one relates differently to that attractor value. On the GLSL itself, we also have, in addition to this smooth inverse, which I'll turn down right now, we also have things like the delta. So this is how fast we're stepping through various parameters. So if I move that up, it will be a little bit more active, perhaps. And I'm going to turn these down to like smaller values, and this one to a higher value. So this is something that is kind of modular to play with. There you go. And what's cool about this is it can also be attached to things like, let's do, it can be attached to PLYs. So let's find a PLY of me, search the Mac. Computer is insanely full right now. Okay, so if I bring in this point cloud, kind of more, we'll do this more old school. So what I'll do is I'll separate this out, into my red, green, blue, and I will rearrange it on color. This is using the new pop for point files, so we can see that's now working. So I don't give a super massive texture. I'm going to rearrange. Or sorry, I'm going to thin on the random, and then I'm going to export my data for position. And so yeah, accessing the P there, which is great. Okay, so we can see that I'm now inserting that. And then if I wanted to add in any kind of color, it would be a similar process. I would just copy this and access the color. This obviously could be refined if you are working wholly in chops, also wholly in pops. But right now, this is sort of the framework that I am going with. Okay, and then I would apply this. Aha. So actually, I wouldn't need to do this because I do flip into working with. Pops later on. So what I would need to do is insert this attribute combine, which I already have set up. That's gonna feed through that color. So this is a way, and it's kind of intense on that feedback. It's kind of intense on the attraction level of those particles. But this is a way that you can create pretty cool attraction effects. Set this both to 1. And because this is GLSL, what I could do is I can, and this might hang my computer, but let's try it. There we go. We can set up a lot more particles. So right now we have 20 effectors, and you can go as high as your computer can go. I have run into a couple of crashes going pretty high with this, but it's it's pretty accessible. So yeah, these are the networks that I wanted to talk about today, and I hope you enjoyed. I'm going to be sharing them on the Patreon, like I said. So there's the free, the patcher, and the component tier for these different things. This one we're looking at right now will be in the final tier, the component. And so I hope you enjoy and hope you have a good time learning about pops. Thanks for watching.